Yeah, thank you for attending once again. My name is Michael Haag. I'll be here with y'all here today. And all of this is recorded, so you'll get this in a follow-up email along with a bunch of additional resources and everything that we talk about here today. And yes, let's get going. So we are going to be diving into the recent Q1 remote code executions with me, Splunk Threat Research Team, one of many on the team, but you got me this time. I'm a principal threat researcher here on the group. I've been at Splunk almost 4 years now, which is crazy. On the same team, most of the team's been the same, which is really cool, good cohesion. And yeah, love to hack on long walks on the keyboard. Love doing threat emulation, simulation. You may remember me from such projects as Atomics on a Red Team. So I do a lot of Atomic Red Team work. And if you keep the pace with other things, living off the land drivers, do a bunch of that as well. Pretty big in the open source space there. So anyway, let's go ahead and dive in. Our agenda is we will be looking at, first be looking at some of the latest Splunk threat research, security content. We'll dive into implementing it, real kind of brief. And then we'll go into demo. We'll start to get into kind of like hands-on building some stuff, and then we'll start attacking it, and then we'll look at it in Splunk, and you'll see a little bit of how our workflow is with taking something from POC to like exploitation to content, kind of like a little bit of that detection engineering workflow piece. Then we'll dive into Q&A and anything else from there. All right, cool. First, we have a poll. And if you're watching live, excellent. Have you deployed any of Splunk's pre-built security detections? You may receive this through Enterprise Security. You may get it from our Enterprise Security Content Update app that we have on Splunk Base. And there may be places like Splunk Security Essentials, or maybe you've cloned it and you use it that way. Feel free to hit ABCD. And if you're not sure, that's totally cool. I wasn't sure even before I got hired here. I didn't know that Splunk had out-of-the-box content. Excellent. I'll give everybody just like 10 more seconds. Wow, there's lots coming in. And I hope it's all yes. Everyone's saying yes, right? Cool. It's fun doing this live. I don't think we've done a poll live before. Cool. All right, where are we at? Okay. One more. Okay, yep, 2 more. Perfect. Feel like a contest here. Like, oh wow, they're just rolling in. 1 more. Okay, I'm gonna move on. But thank you for voting. This is great. That's like 55%. 56. This is exciting. They shouldn't have given me polls like this. This is way too cool. All right, let's move on. Thank you. Thank you for voting. Look at that. Look at all those yeses. Some no's. You're not too sure, and you didn't know that we offered pre-built security detections. Well, that's exciting for all of you. So Splunk Threat Research Team, what we do is we study the threats. We look at what's happening out there in the wild, whether it's like, your malware, crimeware-based campaigns, your adversarial APT, large-scale type campaigns, anything like that. We work to create the data sets for it. So we'll simulate it. We'll use Atomic Red Team. We'll run that malware, anything like that for you, for our customers and whatnot. We write the Splunk security content for it. That might be a data model query. It might be a direct source query, anything like that. And sometimes we develop new tools in that process. And we do have a bunch of tools that we have developed in the past that we've shared. And so all of this is open source. And you can actually access all of it on our research.splunk.com site. And that particular site is right here. I think today we have over 1,600 analytics that you can go and grab. We cover everything from endpoint, network, web. There's a little bit of everything. Analytics stories are what you would potentially call use cases. We have 220 use cases out there. And then we also have a lot of the SOAR playbooks that you can use out the box as well. And all of that's there. And when you're drilling through the site, you have the option to, like, sort by, I think, data model or MITRE, anything like that. You could drill down and look for specific pieces. We even have a MITRE matrix on there. So if you're looking for something to kind of show, where all of our content is at, it's pretty cool. And so, yeah, I mentioned we can get the content. We deliver the content through a couple different ways. Splunk Security Essentials, and then we also have our own app, which is the Enterprise Security Content Update app. Both of those are on Splunk base. And if you have our premium app, which is Enterprise Security, it all gets delivered to that as well. So kind of like 3 places, and it all shows up. So if you're using one of 3, you're probably getting our content. And if you hit update, you'll get the latest content. Yeah, they gave me another poll. And so this is another good one. And so while you're looking at that, did you know that the Splunk Threat Research Team regularly releases new and updated security detections? That is our next poll. There should be bunches of yeses. But that's okay. If you didn't know it, it's totally fine. We do release on a regular schedule. Now you're going to know. Now you get to hit yes. We release pretty regularly. About every 2 weeks, we cut a new release. And that is on our GitHub if you want to go see it live. We have all of the work out there on GitHub, along with, again, we push it out all the different apps. So you'll see everything there too. So, all right, we're at 58%. Now that you know, everyone gets to hit yes. I'm going to pump my numbers here. Here we go. We're at 85. One more. Okay, cool. All right, we're at 59%. I think that's pretty good. I'm going to hit next. So yeah, most of you said yes. Great. Some of you said no. That's okay. Now you know. All right. So before we get into all the fun demos, we did want to at least share what we've been up to the last few months, January to March, like the Q1 timeframe. You may remember it was wild out there on the web. There was so many remote code execution vulnerabilities being released left and right, all from appliances to remote access software, build servers, everything. It's just been crazy. And I still feel that, like, this end of the year, 2023, last year's end of the year, coming into January was just a wild time. If you remember with Confluence, all the different vulnerabilities that were just dropping. And we were watching, and you can see this from like Gray Noise and other sources that are monitoring the internet. Like, it's just the scannings are relentless. It's just constant. And then with like JetBrains and Jenkins and whatnot, and Avantis and FortiGates and Fortinets, and everybody had something happening this year, and it's been really wild. Fortunately, we've been there. We wrote some really cool content. We've been tracking things and writing and pushing out new content. And so kind of starting with Confluence, so much had happened with it. We developed a analytic story here. I got to the place where instead of writing individual pieces of analytic stories for different things, I was just like, let's just create a default, a base use case analytic story and just tag things to it, because these things aren't going anywhere. So yeah, this one in particular just has the most recent Confluence analytics tied to it. And again, you can find these on the research site, research.splunk.com. Same with TeamCity. TeamCity is like a build server. It's a build application. You put your source code on there and you build software. And apparently people put it on the internet, which may or may not be a good thing, but it had some really interesting vulnerabilities released, which back in March now. So there was 2 CVEs for that one. And that leads us to Jenkins, which is yet another DevOps type tool where it does, open source or automation, build server, deploying software and whatnot. This was back in January. Yeah, let's go ahead and I'm going to go forward because I want to try to save as much time for our cool demo here. But in the midst of it all, I wrote some blogs here covering Jenkins, TeamCity, and Confluence, and we'll send out those links here. But all of these are on our site, easy to search for. We try to make it easy by just saying security insights in the tag there, so you can actually go and like view them and scroll down. All of my blogs focus on how to find these as far as like exploitation, and then how to exploit them, or how to build the application to exploit them if you are looking to test things out and gather log data. And that's kind of what we're going to be doing here today too. So those 3 blogs. And then in the midst of all of the remote code execution stuff, Mauricio wrote an amazing, detailed, thorough blog on email collection techniques for Office 365. And this came with a release, I think, of like almost 20 new analytics or so, all focused on M365, adversaries collecting data. Mauricio also released a new tool to help with to help defenders to simulate that activity, to generate that log data so that you're able to do it on your own, collect that data, and make sure that you actually have coverage for it. So it's a really great blog. It's our Hunting Through M365 Invaders blog series. So that's out there too. And then we have, we kind of break our work up into three spaces. So adversary tradecraft is the other one. So this is more of our malware type campaigns. And so Theoderic here wrote 2 blogs, one on Femidrone Stealer, and Snake Keylogger. And the way he breaks these down, if you haven't read these blogs before or seen his style of blogs, they're focused on reverse engineering the malware itself, extracting the key indicators, and developing security content for that based on it. It's not so much just giving indicators of that point in time, but showing you where at inside that code in reversing it, where those particular behaviors are coming from. So it's really detailed, very thorough, and great breakdowns. So if you haven't checked those out, definitely go and fire those up in your browser. Let's see here. I was hoping for another poll, but there's no more polls. All right, so cool. We saved some good time here. So today we're going to be focusing on building a really cool environment that's going to contain Jenkins, Confluence, TeamCity, all 3 of them, and then we're going to simulate attacking them, and then we're going to go look at the data in Splunk. So this is kind of our workflow when we are developing content. And so we typically want a proof of concept script, wherever it may come from. It helps to have a true exploit. So if you have used Metasploit in the past, it's a great way to truly exploit it and get a reverse shell back to your like C2 or back to your interpreter or whatnot. It's a great way to do it. If you don't, other ways to simulate that I've played with, we'll talk about too as we're going through it, is using like nuclei. Nuclei is typically what you'll find really fast when one of these CVEs drop for remote code or for any kind of exploit to one of these web apps, or even like a FortiGate, anything like that. Nuclei is extremely fast. Someone will push a PR and you'll start seeing the scanning behavior almost immediately. All right, so let me share my first screen. It's gonna get wild. Let's see here, this one. All right, so flip back over here. You're probably seeing a browser. Yes, you are, perfect. Okay, so we are going to high-level architecture, and yes, I'm using Confluence to share my high-level architecture. I thought that was cool, and I can't click it. It should be clicking. The idea here is that what I typically build in these cases is I want to try to capture web traffic. I want to try to capture the application logs from the app. So if it's Confluence in particular, or Jenkins, or whatever it may be, I want to capture it, and I want to capture it centrally. So what I normally do is I deploy an Nginx proxy, and within Nginx, I give it other files that proxy the data to the web server. This is an older architecture right around the time a lot of the Ivanti vulnerabilities were occurring. And so I just spun up a bunch of different things, and then I proxied it. And then over time, I got really tired of deploying, like actually building Confluence from the ground up. And you'll see a lot of threat research teams, what they'll do is they'll use Docker. And so I found a cool project called VulHub, and it's Vulnerable Hub, and it's like Docker Hub. And so you can deploy a lot of these apps inside of Docker as a container. And so now what I do is I deploy Nginx in the front. I do proxy passes to the different ports that each of the applications listen to or listen on. So like 8080, 8090. And then I do a couple other little magic things in Nginx. And so one machine can now host 3 or 4 containers of vulnerable applications. And then I can go and test the POCs and gather all that data. Because again, I want that web traffic. If I can get application logs, I'll get application logs, everything like that. And then again, we push all that out as security content, and we put it in the blog and things like that, so everybody can get all that stuff. So yeah, that's kind of what we're looking at. And so I share, I have a couple links I will drop, and I'll make sure we get them out. And I'm trying to make sure here if there's even a chat window I could drop these in, but I can't. Okay, there's the first link. I'll pass that to my team. And then the second link, I'm just dropping the links real quick. Okay. So again, I use Docker, we use Nginx, and so I wrote a little detailed step-by-step guide here, just kind of starting with installing Docker, very basic stuff, just kind of copy paste. Same with Nginx, and so you just copy these, paste them in. I found over time, the more you do up front, the less work you have to do when you're actually configuring a lot of this. So I already kind of moved the Nginx comp file as a backup and the default as a backup in the sites available here. And then I give a very basic setup for using Jenkins with Docker and Nginx. So again, remember the workflow is we're going to deploy a container of the vulnerable application. We're going to put up Nginx proxy in front of it, and we're going to proxy everything to it so we can capture the data. And so the commands here, all this, and then the Nginx comp file as well. Now, if you work with Splunk or any SIEM, or if you're an admin of web servers, this is a completely custom config for Nginx. And so I log everything in a key value format that's specific for like Splunk in particular. And so this will actually log in a KV format to go into our web data model. So if you use data model queries, this works really well. If you don't, then you have some really good raw data. The most interesting thing that I added here, which you probably won't see out there in the real world, is what's called the request body. So anytime you access a page or an adversary is poking at Confluence or Jenkins or TeamCity, a lot of these payloads are coming in through the request body. And without this, you wouldn't really see a lot of the like real malicious activity. So that's one of the big things I add in here. And so that's just the Nginx comp file. Now, if you haven't used Nginx before, the idea is that we're going to pass it other configs of like our backend web server of Jenkins or whatnot. And so we do an include here at the bottom for sites enabled. And what we put inside sites enabled, it might be the default page, it might be a file named Jenkins, and then you just post this in here. So our Docker container is deployed. This is a lot of setup here. So our Docker container is deployed. It's listening on 8080. We're now going to proxy traffic that comes into Nginx, comes in, hits Nginx. Nginx says, hey, this is going to the server name of jenkins.catjamfest.com. And it proxies it right to that Docker container, which is vulnerable, and allows us to test out that exploit or POC or anything that we want to do with it. So yeah, once you do all that, then you just restart Nginx and you're good to go. And then you can start testing your POCs. And there's a lot of content. So we probably should just go into all the fun stuff. If you haven't seen VulHub, this is what it is. It's a very easy way to, again, test out vulnerable containers. And on the left, you can see there's lots and lots and lots of applications in here. Pretty much everything that you have seen lately is mostly in here. But yeah, even JBoss, that's pretty cool. But yeah, so just take this, you run docker compose up -d, and then it spins it up. All right, Haag said there was going to be lots of hands-on demoing. Let's go and let's build something real quick. I have a new machine ready to go, and I'm kind of following the steps that I shared in that gist. There we go. There's a terminal. Wouldn't be a tech talk without a terminal. So we're going to install Docker, and I could make you watch paint dry, but that wouldn't be too exciting. And then as that's going, I'm just going to kind of talk and share a little bit about some of the other servers here. The idea here, again, is we're deploying these vulnerable containers so that we could test out our POCs and verify things work and whatnot. This is actually kind of exciting. It's going pretty quick. So what I will do is I'm going to flip over to one of my other servers here, just kind of give you a little bit of an idea of how I build them. So this is just one of many hosts I'm running for our demos here today. I mentioned I was running Docker, so you could run Docker PS, and you'll see here I'm using the Volhub Jenkins server, and the file itself is just right here. It's just a Docker Compose YAML, and inside of it is just the Volhub Jenkins. And all you really have to do is just run Docker Compose -D, and that will start the server up in the background. And then once it's going, it will start listening on 8080. And you could access it on 8080. The reason why I'm not is because I want that Nginx piece in front so that we can capture all that cool, wild network data. All right, so we're over here. We're just going to build one live and then also see what happens. Okay. What's next? So we need to install Nginx. So the next step here, have another copy paste. Here we go. This is just going to go and install Nginx for us and move those two files. It's going to hit yes again. Excellent. So now that those like main core components of what we need, Nginx and Docker, all ready to go, I'm going to flip back, not to that one, but to this one here. So we mentioned Jenkins on this box. Typically what I do, and I shared that Nginx comp file, you can go into etc Nginx comp. And again, this is that same file I shared. And kind of like the more important piece, like I mentioned, is the fact that it captures those request bodies right here. And then down here at the bottom is those includes. And what does the includes look like? So if you go back to here, sites available, and I think I put it as the default. Yep. And so our server is on jenkins.catjamfest.com. So as somebody accesses that, it hits the Nginx box and gets proxied to the container, which is listening on 8080. The nice thing about it is if you deploy many of them on one machine is you don't have to expose 8080, 8090, and all these random ports. You could just expose 80. And as you're accessing it, it's just proxying it right to that container. And you don't even have to like deal with all these extra ports open or all ports open and whatnot. So yeah, this one's built. This one's ready to go over here. And we want to, let's see, let's go back over here. Do we want to keep building that one? Or do we want to just go and start exploiting Jenkins? Well, how do you know Jenkins is running? That's everyone's first question, right? So let's go back to our browser here. Let's go back. Okay. So we have Jenkins. Oh, hey, there's the Jenkins blog. So again, a lot of the same workflow is in the blog, and we break down the different components of the POC that we're going to be showing here in just a second, and show some of the example request bodies, as I keep mentioning. And here's Jenkins at catjamfest.com. CatJamFest is a very important festival every year, and they need to have a Jenkins server exposed to the internet. And so I really don't know what to do in Jenkins. I've never used it, but you can create a job, set up an agent, do all those fun things. And that's Jenkins, right? All right, Mike, take us back to the terminal. Let's find out how to exploit Jenkins. Go here, So we have our Jenkins box running. We saw that it was available on the internet, and we're going to use our good friend here now, Metasploit. If you haven't used Metasploit before, you can spin up like a Kali box anywhere local and just do our MSF console on the terminal. A quick way to find whether Metasploit has that vulnerability, you could go to Metasploit's GitHub repo, look at their PRs, look at all the content, do searches. Or if you're in the MSF console, you can just search Jenkins just like that. And it's like, wow, there's quite a bit of Jenkins activity over the years, as you can see. These are all the dates right in the center. Now we're looking for the most important one here, which is down here in January 2024. We're going to go ahead and just type use 17. So much faster. If you haven't used Metasploit in a while, you used to have to like type the whole thing out. Not anymore. I really dig that. All right, so now we're in the 17, which is the Jenkins vulnerability. We're looking to exploit here. You just type show options, and this will show us our options for this particular exploit. So you could change the file path. The file path is what we're telling it to read from the server. So in this case, just etc password. Tell it the remote host. You tell it the port, which again, we only have to hit 80. And our Nginx server proxies everything from there. And when you're all ready to go, you just type run, and we'll ship that down range. Hopefully, there it goes. And so yeah, our little output here says the target appears to be vulnerable, and here's your etc password from your remote server, and I saved it for you. So pretty cool. You can get some data from that. Now on the Jenkins server, or in this case on the host machine with Nginx running, you can go to your var log Nginx and look at the Jenkins access log. I output the app name for access or error in here to make it easy, because I do run some of these host machines with multiple instances. Actually, we're going to go ahead and just do tail -5 on this. I typically run a lot of them, so it can get kind of crazy. But so that didn't give us it. Let's run it one more time for funsies. It's probably because I clicked around. Ah, there it is. Okay. And you'll see our exploitation attempt right here. And again, if you're not capturing, if you have web server set up or if you have a proxy and whatnot, go check, see if you have request bodies. Obviously, if you're running like Snorts or Okata, things like that, it's going to perform some level of deep packet inspection, and you'll see these types of things going across the wire. In this case, the way the exploit or the way the vulnerability and all that works for this is that it passes these to the request body. And so you can see our etc password. And so if an adversary was poking at your Jenkins server, you would end up seeing you would see a lot of hits coming in, pretty hot and heavy. If they're saying, hey, etc password, do an ls of this directory or show me these files, it can get really noisy from a single source. So it's kind of neat to see it live. You can see the URI path right here. But yeah, so the Jenkins one's pretty cool. I think the next one that's even cooler is going to be the next one we're going to look at. Let me go ahead and flip back to our browser window here. Lots of flipping. Let's see. Jenkins. All right. So we read some files with Jenkins. That's exciting. And this is that Jenkins arbitrary file read analytic story we developed. And you could just take this query, run it in Splunk, and see what it's looking for. And so again, we're using the web data model. We're looking for a post, and we're looking for that status of 200, kind of all in there. Some TAs, technology add-ons, whether it's from Jenkins or a third party, or if you're developing it, do and do not map to the web data model. So if it doesn't, our recommendation here would be to just rewrite this query for your data set. And some of the application TAs, so like a Confluence TA, it may map it to the web data model. And that's why I write them to the web data model, is that because a lot of the main product TAs do map it to web. So you're able to kind of go, and I'm talking about like the application logs, the event logs or access logs. They map to web data model. So you have a good chance of actually hitting it with these and seeing everything. Just makes it a little bit normalized, but if not, just copy paste and kind of go from there. Cool. So that was number one. And then we have Team City. Team City was cool. Another automation build tool. And so again, when Jenkins dropped, Team City, even Confluence, widespread scanning was all over the place. And so in this case, Team City, in this one, Rapid7 found these ones. It was back in February. 2 CVEs. I think, yeah, one was a 9.8, the other one was a 7.3. One's a path traversal. The other one's an auth bypass. And so what we end up finding with this one is kind of funny is it just adds a user to the server. And so they have a pretty standard path on this. So if you're looking for URI paths, pretty standard. We did see it change over time as scanning was starting to pick up. We saw some of the paths change. And then as also mentioned in the Rapid7 blog, they were like, yeah, there's some other points of endpoints to go and monitor for as well. So put that all in here. The way Nuclei did it was they were looking for these three. And if they found those three, you most likely had a vulnerable, or if it found those three and it responded back properly to Nuclei, you would end up having a vulnerable box. You can do whatever you want. And so in this case, it walks through the same steps that we did for building our container. As you can see, I kind of put it all in here too. So just pull down your container, run your exploit, and it adds a user, and you can log in and go from there. Okay, so here's Team City. I got it going, and this is again at catjamfest.com. Again, CatJam, this group likes to put things on the internet. They have a wide dispersed development team all around the world. And so they want to make sure their team can access these things anywhere they are working. That sounds like any other organization, right? All right, cool. So let's flip over here to our, I think this is our main one. Let's find out. Yes, okay, cool. This is Team City. All right, so on this box, I have two containers. I actually have Confluence and Team City running on it. And so I mentioned we could proxy with Nginx to both. So if you're hitting confluence.catjamfest, you'll go to the Confluence server. If you're hitting Team City, you go to Team City. Pretty easy. It's all set up. Let's just go ahead and go straight to exploitation here. I'm just going to hit back. I'm going to go right to searching again. And this time we're searching for Team City. And thankfully, we have the latest one here, which is what we want to play with, 27.198. And I'm going to do use, what number is that? 3? Perfect. And then again, just type show options to see what options you have. And I already got it filled in, which is handy. Port 80 and then Team City for CatJam. Yeah, I think that's it. We'll just send it down range. This one could be a little noisy. And if you are collecting the Team City logs, you will see a new account get added. And it was actually kind of neat. Metasploit itself added these like pieces here that, you know, it may require manual cleanup. And if you're looking at the Team City logs, the app logs themselves, you'll see these like randomly generated things being dropped and put onto the box and whatnot. It's actually pretty cool. It's a powerful little app and whatnot. I did not get a session. I think it's just some networking stuff that I did not want to work out. But you can see it was vulnerable, ran all the things, uploaded the plugin, did that piece, and then added a user. And yeah, and so from here, again, you could do var log. Actually, we'll do tail. Var log Nginx, and then I told you I named them by Team City. Go access log, and then you'll see here. You'll see again. So we're coming from the outside as an attacker here. You can see the access to the plugins piece, and then the URI paths of a plugin and whatnot. I think you're seeing the request bodies and all the different pieces that it's performing. accessing the access tokens and everything like that. But yeah, that one's pretty cool, and it worked really well. Let's flip back to our browser real fast. Getting good at this. Hopefully everyone's still following along. I don't think it's a snooze fest, right? I don't see comments yet. Okay, back to Team City. So yeah, I wanted to show, not that, where's Team City? Right here. Yes, okay, mix things up. Yeah, so this is the analytic story. We talked about the auth bypass and whatnot. So I wrote this in a few different ways. I had Suricata data for it, and so you can click in here and kind of look at what it's doing and the different paths that it's accessing. This one was pretty cool. A lot of access to the users or tokens and things like that. So it's kind of one to look for. It was pretty hot and heavy when it first dropped because Team City was on the internet and people were scanning for it. And then the remote code execution attempt piece was looking right here to this URI path. You'll see a lot of post requests to it, very similar. And yeah, so there's Team City. I know we have a blog for it. I must have missed it. Oh yeah, we already talked about the blog. Yeah, so I mentioned the audit log straight from the Team City application. I did capture those, and I think I dumped them out to our other project, which is called Splunk Attack Data. And inside our attack data, you can access all these event logs and view and check them out too. So I was just showing screenshots in the blog, giving you a quick idea of what these look like. You can actually access them straight in the UI of the product, and I give the URL just in case you want to go and validate that or play with it yourself with the product or within the container. But yeah, that's that. The blog goes into obviously a lot more detail as you're seeing as I'm kind of scrolling through here. Again, we mentioned we built this against Suricata. We built it against the web data model, just trying to give options. If you're looking to deploy this or you have Team City out there, even if it's internal, it doesn't have to be external. You should monitor the data from these things. Yeah, get Splunk on there, start logging it, get it going somewhere. Don't just tail the logs like I did and hope that you can find it, or grep it. If you're a good grepper, go for grepping. But yeah, check it out. Yeah, so, all right, save the bread and butter for last because Confluence is a lot. So I wanted to start with first showing Nuclei. If you haven't heard of Nuclei before or played with it, this is Nuclei. What I did is I did a search for Confluence, and I wanted to just show, I'm kind of going back a little bit to October timeframe when the main vulnerabilities occurred and came out for Confluence last year, which led the way for a lot of early January's like exploitation, because once adversaries or researchers started realizing that these were so simple to exploit, it just kind of blew up. And so last year when 22.515 came out, it was like instantly it went into Nuclei. And so Nuclei is a scanner tool. You just take this template and you say, scan with this template, and you'll see this all across the internet. It literally just goes around and does GET requests looking for that URI. And if it gets a response back, it's like, yes, it worked. And you can see there's tags and it tells, different pieces. But there's a bunch of them. And this is actually a really good place to go if you're just trying to see what's up and coming as far as like new things people are scanning for. Their PRs, as you can see, there's 56 right now. It's loaded. Like there's a lot of rich data in there. And so here's another one. This is for 22.518. This was the next one that came out. So after 5.15, we saw lots of scanning for that vulnerability, and then 18 came out. And these were pretty close back to back. I created a diagram inside of Confluence of all things. So I wanted to kind of visualize it. It makes more sense, right, if we can see it visually. So Mike, you're talking 22, 15, and 18. What do all these mean? So we see this was released October. And then we started seeing active exploitation just like maybe 10-ish days later. what was crazy, and I think this was probably the craziest part, right, is that when these dropped, Confluence or Atlassian didn't publish the patch yet, and it took a while for patches to get dropped. So as these things were getting exploited out there in the wild, yeah, it was crazy time. And then it wasn't long after that, you see the 18th is like, yes, let's go patch our Confluence server. That's exciting on a Saturday. And then you're like, what happened next? 518 drops on, apparently, I didn't realize this, it was on Halloween, October 31st. And then it was only about 5-6 days later, we actually saw reports of active exploitation with ransomware operators going. And so it initially, good or bad, 518 came out as like I think it was I was just looking at it earlier. So here's 518's report. Yeah, wait, right. Where does it go? Where'd it go? Was it this one? No, it was, oh yeah. Nope, not this one. One of them came out. Yep, here it is. It came out as a 9.1 CVSS. So if you kind of like base things on CVSS, 9.1 is pretty bad, right? Well, it was like, yeah, adversaries are now exploiting it. We just bumped it to a 10. It's like, wow, like these things escalated so fast. And that was on November 6th. So it took a couple days, about 5-6 days for that to just go from like a 9.1, which is crazy, to a 10. Let's just get crazy here. So as all that's going down, you know, you got holidays, you got things going on all around the world. You're still seeing tons and tons of scanning on the internet of people looking for these two vulnerabilities. And so I wanted to show a little bit of what we were seeing. And so I copied out the base of what 22.5.15 was looking for. And these were hits going to these particular URIs, looking for like finish setup and setup administrator. What was kind of weird about it was like basically almost doing a reset of your Confluence server. And that's where 518 got crazier, is they initially were like, Confluence came out and they're like, yeah, look for people hitting setup restore or setup restore progress or local. And then once that took off, we saw the ad of the part of the URL here, the URI of the /JSON. It was a mess. Like, hopefully everyone remembers this time because it was a wild time. So these two things started happening, and it allowed people to, again, these were tens. I don't know, we're focusing on an older one here, but this is the broken access control vulnerability. And then this one was the improper auth vulnerability. So all these start happening. I got some cool screenshots in our Confluence server. So here's our hits right here. This is my Nginx box here, collecting all this wonderful data. These are people coming in and hitting it, or me hitting it, all kinds of activity going on. So neat. And then January comes around. And as if there wasn't enough, right? Let me close these tabs. We get 22.5.27. We get a cool remote code execution against these same servers. These poor things cannot make it a week. Straight up, it was a 10 right out the gate. Excellent, do it. And it was just bad. So that one's actually really cool. And so I have the remote code execution attempts here, and everything basically goes in the full request. And at the time, what we were seeing was, hey, we were seeing nuclei scanning. We were seeing, we were seeing 518, 515s coming in, looking to see if we could reset or add a user. And then we started seeing remote code execution, which led to that one, that screenshot right there. If you're running enterprise security, I thought I'd throw a screenshot in there, but that's what it looks like in ES. This was someone hitting it, me hitting it, or somebody hitting it with Python. It's one of the different POCs out there. And so here's what it would look like. Typically, it was just a post request to this text in line endpoint. And then within the request body, and here's the important piece, is those request bodies, you would start to see, and if you were hitting it a lot, you would get a ton of requests with all kinds of different request bodies. And you can see on the far right over here, these are the different commands that they would run, that the POCs run and everything like that, listing out directories and paths and whatnot. and eventually caught all kinds of cool commands being ran against the box, which is really neat. And each one of these was a separate request. So imagine, here's your who am I. Imagine just getting hit on your Confluence server, which is a bunch of these requests. And you're, whether it's like your IDS or IPS, or if you're looking at request bodies and Splunk or whatnot, like this thing just lights up one machine and a bunch of these really long, crazy bodies in the request there. So yeah, it was a lot of data, and that one was pretty fun. Again, we created an analytic story. We cover the two main ones here, which is the Privesk, and this one was the setup administrator finish setup one, looking for the JSON endpoints. And we actually found a few other locations they were poking at, which is kind of the power of having these little containers. And then the 22527 RCE. And so this one's looking for just that text in line. Each attempt would be a post. We saw 200 requests, but the other one was a 202 request. I couldn't tell you off the top of my head what a 202 is. But yeah, so we added that in there just as extra avenues. You could gather the straight Confluence logs and just modify these queries for those logs themselves and look for those endpoints coming in. And it's not too hard. Whew, boy. All right, let's go back to our terminal. Everyone's here for some Confluence exploitation. I have already heard the excitement. All right, let's go where we at. Okay, so we have oh, look at that, I already had the data. So this is again our Confluence box here. Where are we at? We're in the, okay, yeah. So I just deployed a different vulnerable Confluence server, and this one comes from, I think it was Datadog, who released a similar container to Volhub. It's the same thing. It's just a different way of running it, I guess. So I deployed that. You can do your Docker PS, and you'll see our Confluence server, which also runs a Postgres database, and they basically just chat and talk to each other. All your data goes into the database. All right, so now back to our Metasploit. I'm just gonna do a search for Confluence, and hopefully it's not too many, and there's quite a bit. You can see there's a lot going on, especially the later ones here, 24s and late 23 here. Let's go with this number 27 for funsies. And this is the main one. This is the 22515. I'm just going to clear screen so we get back to the top here. And I'm going to do a show options. All right. So cool piece is that you can actually change your target endpoint. So remember, I called out, like, you could hit the /JSON, or you could do the server admin. Like, there's a couple different ones out there. And if you're looking to gather more, check Nuclei, check our blog, check Metasploit itself. There might be some other ones in the documentation that they recommend. And then our server, in this case, it's confluencecat.catjamfest.com. And that's it. Just run it, and port 80. And so this one goes, it hits our little server, starts creating a little user, does the plugin work. And let's go back over here. So it should have triggered the payload, which then led to that remote code, or yeah, that would have at least, oh, wrong file. Let's do a tail on our Confluence log here. Yeah, you can see it got a little crazy. The big thing, right, is there's some really sketchy pieces here on the URI paths as far as like somebody adding something to your Confluence server. Now, if as a like a Confluence admin, which I am not a Confluence admin, you would notice a new add-on, a new plugin coming in and being added to the server. Maybe you would definitely notice a new user being added to the Confluence server, and that's right here. So they do work based on those type of behaviors. If you were monitoring or tracking things on the internet as these things were being scanned out there, you would see people adding users that say, like, patch the server, please. And they just kind of went on from there. All right, we have time for one more. Let's find the, I guess I could have hit up. Let's find the 2024 one here. Let's do number 23. Sounds good. Clear screen, so we're at the top. Show options again. And we're all set. ConfluenceCat .cat.jamfest this time. And let's see if it works. Port 80, run it. Let's see what happens. There you go. There's that OGNL piece. And I'm going to flip back to our log. And now here is that same request body I share in the blog. And we talked about a little bit in our Confluence page. Here's that URI path, that text in line, and that other piece of the request body. So yeah, that was a lot. But Mike, you didn't even talk about Splunk yet. Let's go back to our browser. Okay, so I'll make this one quick and easy. I actually created a dashboard where we can see everything in one place because I was worried we would hit this limit. So again, all I did is I took those queries straight from our research.splunk.com site and I ran them, and then I just basically saved them as little tab pieces in here on a little simple dashboard. So here's that remote code execution. The way the data model works is the request bodies are not added to the data model. So what you get is kind of just URL, status, is it a post or whatnot? All that's there. Here's our Jenkins reading files. So as an adversary's going and requesting a bunch of files on your box, they hit this endpoint, and you can see there's quite a bit of little activity going on. And then we have our JetBrains Team City, and you'll see all these different requests coming in to multiple different URIs. There were instances where the path traversal piece was pretty long because people want to poke. And then there's that remote code execution attempt. 22.515, again, server info, a lot of Metasploit and different POCs were hitting that one. They kind of cascade, right? So as like Nuclei releases something, a new POC releases something, you start seeing scanning for different things. And then down here is just the different request bodies from Jenkins. So you'll see all the different RCEs listing out all these different files out there as well. So yeah, thought that was cool. And then what's this? Oh yeah, just raw data. Okay, so all right. I want to make sure we have time for Q&A and make sure we get back to the slides here. Okay, I think you can see the slides. Next slide. Key takeaways. It was so much content. Remote code execution vulnerabilities. They ramp up really fast. Obviously, the biggest thing is knowing your perimeter, knowing your own threat model, what is out there on your perimeter. These things go quick. You'll start seeing scanning the moment these things drop publicly. POCs get created, Nuclei gets created, Metasploit will probably spin up, and you'll start to see a POC developed in there. We're here to help. Think of us as an extension to your team. If you're looking for this latest content for this latest vulnerability, we probably have it. And we're probably have already pushed the content, or we're about to push the content for it. And so you can use a lot of that. You can modify the content for your logs. If you have like just native logs and you just want things to hit it or write queries against your native data, you can do that too. And yeah, check it out. Go to research.splunk.com. You can see all of our content there. We do have lots and lots of blogs that the team writes. Again, for any of the emerging threat stuff, we try to get it out there pretty quick, hopefully within a week of it being dropped publicly. But we also want to validate with a real POC. We deploy these containers, test it, make sure things actually work, and collect good data so that we're shipping really good data. All right, so Q&A. Submit your questions. I think you have a box where you're able to submit things. Let's see. Thank you for the comments. I'm just going to go to the next slide because I want to make sure everyone can see it. So additional resources. They're going to let me talk again. So after you saw all the terminals and browser switching, we're going to do an office hours on June 9th. So if you have any more questions, you can definitely come to that. That will, I believe, be in a follow-up email where you can like register for it and come back for that. Let's see. Quick question about .conf. Yes, there's a link, or there's a thing right here to save the date for conf. The whole team we'll be there for that. And yeah, most of the whole team will be there. So if you're going to .conf, I think we have a booth, and you can come hang out with us at the booth. It's a little booth, but it's cool. And we're doing a bunch of talks. We have a bunch of talks on Thursday. I think it's the 14th or 13th or 14th. Yeah, documentation, all that. Blog link here. Again, this will all be in a follow-up email. Yes, we'll get you the gist links as well. All right, one more question here. Oh, yes, we will get the links posted. Yeah, we're going to post the links to the gist links on the community. So all of that will be there too. And then try to find, is there any? Yeah, let's see. What's the next slide? Oh yeah, community. The links are here. It's just community.splunk.com. A lot of this content always ends up there. You'll also see the registration links for the follow-up on June 9th, which I just realized is right before .conf. Was it on June 9th? Let's go back. Yes, it is on June 9th. Cool. And then, so yeah, office hours, don't forget that. All right. Cool. Yep, perfect. And yeah, that's all. Thank you for hanging out. If you have any other questions, throw them in there. Again, we'll get the links and whatnot shared out so that everybody has them. Be on the community site. And this is recorded. You will get the recording as well. So if you wanted to see more of the follow along or kind of like how all this happens and throws down, we'll get that to you. And then, yeah, if you have any questions, feel free to, send us an email or hit us up in the Slack, community Slack, Splunk user group Slack. And then we also have, what is it? There's email, Slack. You can find us at GitHub. If you have any issues or comments like that, drop them into the GitHub issues. But yeah, thank you again. Thank you all for joining. Appreciate it. It was quite a bit of folks here today. Appreciate it. Let's see. That's it for slides. They don't let me go past that. Well, thank you all. And oh yeah, there's a survey coming out. I think it'll be in your email too. So if you're still here, we should do an after hours. I don't know if they'll let me go longer than this though. All right, everybody. Thank you all for listening. Hope you all have a great day. Have a good weekend. And if you're watching virtually, thank you again for coming back to watch this. And you're still here. And you're still here watching. Thank you. Thank you for that. Cool. All right, everybody. Talk to you later.